Now the next destination on our way to the archive is the archive cache. The archive cache is the structure in memory that ends up holding 256 events for each pi tag. Now that data is replaced on a least recently requested basis. So in other words, that the cache contains the values that were the most recently requested by users. So as we are getting data into the cache, that data is left in the cache. The data that's being written by the interface towards the Pi server and to the Pi server is going to be left in the cache until we replace it with something that's more recently requested. And also data that's being requested by users is also left in the cache, and we use an algorithm to decide which values are going to be replaced. And again, it's on a least recently requested basis. So generally the current data, either it's currently been requested or it's currently been written to the cache, is the data you'll find in the cache. And of course the benefit of this is that when you're trying to see some information, it's very likely that information is already sitting in the cache. So you don't have to go out and haul that off of disk in order to get it. Now, you'll notice in discussions of cache that we do have a 15-minute cache flush rate. Okay? That is something that's user configurable. That's something you do in the timeout section. But the values basically are not immediately written to disk, but every 15 minutes we flush the disk any values that have not yet been written to disk. Now, that can be a confusing statement. I think the important thing to take from this is this right here. It's going to flush to disk any value that have not yet been written to disk. Now normally we would immediately, if we could, we will normally write data from the archive cache to disk. So usually this is within seconds, if not milliseconds, of getting data into the cache. We write it to disk while keeping it in the cache, and waiting for that least recently requested algorithm to kick in and make sure that it stays there as long as people are interested in it. So we normally do write straight through to disk, but just in case, for whatever reason, the system may get very, very busy and we have not had the time to do this write operation, then that's why we have this 15-minute cache flush rate. See, it's kind of a fail-safe mechanism. If there are values that have not yet been written and it's been 15 minutes, this 15-minute cache cycle is up, then at that point we will take all those values that have not yet been written and we will write them to disk. So technically, if you were to, somebody to kick the power cord out of the wall on your computer, the most that you'd lose is going to be 15 minutes worth of data. But remember, that would be a worst case scenario. It's very, very likely that the data that's sitting in the cache has already been written to disk. One minor point, I should mention that the data that's in the cache is actually the data that you will see. The data that's in the queue, the event queue, is not viewable by the clients yet, but the data in the cache obviously is viewable by the clients, and that's one of the reasons for the cache, is to make this data, or serve this data up quickly to the clients. Now you also find in the tuning parameters there are things like there are things that you can use to modify the behavior of that cache. So we don't typically recommend people make these kinds of changes unless they're on the phone with tech support, and we're suggesting that you assign a greater or fewer number of cache records in the record pool, and that really just depends on the type of data collection you're doing. For most people, the defaults work fine, but we have made the system flexible enough that if you do need to change, the flush interval or the record pool size or the size of the cache, you can do that.